Okay, so this is our part 2 of this week's lecture. So we have already seen how to solve quadratic equation using factorization method, formula, and using graph. Yeah. So now let's see how to solve linear equations and how to solve simultaneous linear equations and how to solve simultaneous equation involving a linear equation and a non-linear equation. Okay, so let's start with linear equation. What is a linear equation? Linear equations involve just, in linear equations are equations which have the highest power 1. That is, the highest order is 1. The highest power, the power is 1, yeah? So it could be 1 or 2, any number of variables, but the order or the power should be 1. That is a linear equation. For example, 2 times x minus 3 minus 1 is equal to 11. This is a linear equation. It's not an expression because you have an equal to sign. You're equating two expressions. Yeah, so it's a linear equation. So how do you solve it? Just what do you do? When you see a bracket, get rid of the bracket, remove the bracket, expand. That's what we did a couple of weeks ago, yeah? So 2x minus 6 minus 1 is equal to 11. Now, what do? Bring the like terms together. So you have 2x, I'm going to bring minus 7 to the other side, or I can add both sides by 7. Then you have 2x is equal to 18, or x is equal to, I am going to divide both sides by 2, and I get x is equal to 9. Okay, so that's how you solve a linear equation to find the unknown variable x. Look at this example. What do you do when you have something like that? We saw this in changing the subject. Yeah, we have seen that similar problem in changing the subject. So you have to make x as the subject. And what do? You get rid of the denominator. So multiply both sides by x minus 2, and then you have 2x minus 1 is equal to 3 times x minus 2. When you see a bracket, what do? Expand, remove the bracket, and then you get x is equal to 5. So what does it mean? Linear equation is nothing but it's got a unknown variable and the highest order is 1, and it can be solved by rearranging the equation. That's what we have done, and then making the unknown variable the subject. Yeah, bring the like terms together, make the unknown variable the subject. Okay, so that's how you solve simple linear equations. Now let's see how to solve simultaneous linear equations. Okay, let's take this example. Yeah, look at that. Here you have two different variables. It's still a linear equation, okay? Because it's still a linear equation because its highest order is 1. Highest order is 1. So it's still a linear equation, okay? The highest power is 1. Okay, let's solve this now, yeah? So we can find a solution for the two unknown that satisfies both the equation at the same time, That is the definition of simultaneous linear equation. Simultaneous, solving two linear equations simultaneously. That means by solving two linear equations simultaneously means you find a solution which satisfies both the equation at the same time. That's the meaning of the term simultaneous. Yeah. So if you find the value of x and y, that value, that x and y, this point satisfies both the equation at the same time. Okay, so let's do it. How do you do it? You can do it by either substitution method or elimination method. Yeah. As the term indicates, substitution means you substitute one equation into another. So you substitute one equation into another equation. Yeah. Elimination means you eliminate, cancel the equation. So how are we going to do that? Let's do that. Yeah. So substitution, good habits. Let me put the number for the equations, yeah? So this is my equation 1, this is our equation 2. Now this equation looks easy to me, so I'm going to rearrange this equation as y is equal to x plus 7, and I'm going to call this equation 3. And now I'm going to substitute this equation 3 in equation 1. So when I name the equation, it becomes easy for me to talk about it, yeah, because it has got a name. It's easy to talk about it then, yeah. So I'm going to substitute equation 3 in equation 1. So I get 2x plus 3x plus 21 is equal to 6. And I call it equation 4 if I want, yeah. Let me call it now. So that's the equation. I'm going to take the like terms in equation 4, which becomes 2x plus 3x is 5x. And then I have 21 and then 6. And then I'm going to bring 21 to the other side, like terms together. And then x is equal to minus 15. And then I'm going to divide both sides by 5. And x is equal to minus 3. So is it finished? No, it's not. I'm going to substitute x is equal to minus 3 in any of these equations, yeah? I'm going to take this equation, yeah? I'm going to substitute y is equal to, because this equation 3 is just a rearranged equation of 2. So I'm going to substitute that. And I get y is equal to 4. So I got the point. This point is nothing but minus 3, 4. This point of intersection is minus 3, 4. Now let's do the elimination method. I'm going to number this equation again. Can I see some relation here? Yeah. I can multiply this equation with 3 on both sides and then eliminate this. Eliminate this. That's what I'm going to do. So first rearrange the equation 2 to look exactly like that. So x minus y is equal to minus 7. Now I'm going to multiply equation 3 by 3. Now I can add equation 1 and equation 4. I'm going to give a name so that it's easy to tell what I'm doing, yeah? So adding equation 1 and 4, we get 5x minus 15. Divide both sides by 5. You get x is equal to minus 3. Now substitute x is equal to minus 3 in any one of the equation there. Either this, that, either of them, yeah? And then you will get y is equal to 4. Same. So you can either use substitution method or elimination method. It's up to you, or any other method which makes sense, yeah? Logically, it should be correct. So that's how you solve 2 simultaneous linear equations. Okay. Okay. Now over to you guys. Please solve these simultaneous linear equations. Okay. Now let's see how to solve simultaneous linear equation using graph. Yeah, I would suggest for this, please use Desmos and check your answer, okay? So first solve this, find the simultaneous solution, then use Desmos and find this, whether your solution is correct or not, okay? So I think that's the best way to check, yeah? So let's see how to solve using graph now, yeah? So there is a well-known English saying, that is, a picture paints 1,000 birds. Yeah, 1,000 words, not birds. That is, a picture is worth 1,000 words, yeah? I'm sure this is there in many other languages. This saying is very common in many languages, yeah? In Maths, a picture is nothing but a graph, okay? So graph tells us the story, yeah? So solving simultaneous linear equation using a graph. So let's take the 2 lines. You are an expert in drawing straight line equations now, yeah, because it's, you know, m is equal to 2 and c is equal to 1. So you can surely draw the line M is equal to 1 and C is equal to 4. So you are an expert now because we did it a couple of weeks ago. And now let's draw together. Yeah. So let's take this equation. Here C is equal to 1. That means the line should pass through 0, 1. And the gradient is 2. That means for every 1 unit you move along the x direction, you move 2 steps up. It's a positive slope. So you move 2 steps up. Every 1 unit, you move 2 steps. Every 1 unit, you move 2 steps. And then join the points. Where did I go wrong? Oh, I didn't move 2 steps. Sorry, guys. Okay, I did a mistake there. Let me do it again. So every 1 step, I move along the x direction from left to right, I move up by 2 steps, yeah? So that's it. What about the second graph? That is y is equal to x plus 4. Here m is 1, c is 4. So that means c is 4. So 0, 4, yeah? That means every 1 unit, I move up by 1 unit because m is 1 and it is positive. So I move up by 1. Oh, sorry. Oh my God, we know where it is actually now. Oh, it's meeting here. So that's the point of intersection. So that is the unique solution. So you have x is equal to 3, 7. That is the solution for the equation. Yeah. Okay. So any two linear equation in general, if I say there are two lines, they will have an unique solution if the two lines intersect at a point x, y. Yeah. In general, okay? We'll have an unique solution if the two lines intersect at a point x, y. Now, if I take another good example, for example, that equation, can you see something there? What type of line will be? What type of lines they are? Or is there any unique solution for that? Do they have a solution? Okay, let's solve that and see. I'm going to substitute or elimination, any method you can use, yeah? I can actually eliminate also here, 2 times, 2 times. So it's all gone. There is nothing there. Yeah. What does it mean? Every point on one line is a point on the other line. Yeah. That means the two equations have infinite solution. That is, the line lies one over the other. Yeah. That's what it means. Yeah. Okay. Now let's look at another example. How about this? Do two similar simultaneous linear equation always have a solution? And this example is a good example for that, yeah? So if I try to solve this, I rearrange equation 2 and substitute in equation 1 in 3. What do I get? That's impossible. How can 9 be equal to -2? It's impossible, isn't it? That means these two lines will never meet. If they don't intersect, they don't meet. What type of lines are they? Parallel lines, yes, they are parallel. So these lines are parallel because they don't intersect. They don't have any unique solution. So in general, if two lines intersect at a point, that means they have an unique solution. One solution. If the two lines don't have any solution, they are parallel to each other, so no solution. If the two lines, every point on one line is a solution of the other point, that means they have infinite solution because they lie on each other, yeah? So this is very important. Your You can see that and you can understand that, yeah? Okay. Now I want you to solve this equation, the simultaneous linear equation, because the highest order is 1, and tell me whether the equation has an infinite solution. That means they lie on each other and they have, or every point on that lies on the other line too. Or they intersect at one point, they have an unique solution, which is x is equal to 10 and y is equal to -1, or they do not intersect and they're parallel to each other. Good, that's right. Now, I want you to draw the graph of the following equation. Yeah, before that, I forgot to say, can you also check your answer using Desmos? Good. Draw the graph of the following equation. You please use a graph paper, pencil, and ruler. Thank you. Okay, now how do you solve a linear equation and a nonlinear equation? Let's see that, yeah? We have seen how to solve simultaneous linear equations, that is by substitution, by elimination method, and then finally using a graph, yeah? We have done that. Now let's see how to solve simultaneous linear equation and a nonlinear equation, like this, something like that. Look at that. This is a linear equation because the highest order is 1. Can you see that? Here, the highest order is 2. Here it's 1. But the highest order is 2. The highest order is 2. So this is a nonlinear equation. This is a nonlinear equation. And this is a linear equation. Yeah. So how do you solve that? It's the same way. Name the equation and substitute the linear equation into nonlinear equation. Substitute the linear equation into nonlinear equation, into the nonlinear equation. So you have, so I'm going to rearrange the equation 1 and I'm going to substitute it in the equation 2 because that's my linear equation and that's my nonlinear equation. And then expand, remove the bracket. Oh, what did we get? We got a quadratic equation and you know how to find how to solve the quadratic equation and find the value of x. Yes, please use the formula. I would suggest please use the formula and find the value of the quadratic equation. And you get x is equal to -5 and x is equal to 2. But now this is not finished here. The story is not finished here. You have to find the solution for y because you're going to solve the simultaneous equation and find a point where the line touches the curve. Sorry for the wrong, where the curve touches the line. You have to find the solution. That means you have to find the coordinates, so x and y. So you have to find the point. So substitute this value, x is equal to -5, in any of these equations and find the value of y. So y is equal to, so when x is equal to -5, y is equal to 4, you got one coordinate. And then you substitute x is equal to 2 here, so you get 2 minus y plus 1 is equal to 0. So y is equal to, this implies y is equal to 3. So when x is equal to 2, y is equal to 0. So you got two solutions. So 5 minus 5, comma minus 4 and 2, comma 3. So that's your solution. That is the point where the curve, the nonlinear line or the nonlinear curve touches the linear curve or crosses where the linear line crosses the nonlinear curve. Yeah. Now I want you to solve this linear equation and nonlinear equation. Excellent, good. So you're going to substitute the linear equation into the nonlinear equation and then expand the bracket, you get a quadratic equation, and then you can solve using the formula. But here, when you solve the quadratic equation, you can see that b square minus 4ac is minus 4. It's a negative number. This means there is no solution for these equations because d is negative. The equation has no solution. Okay, so that's how you solve linear and nonlinear equation. So it's something like this. It's not a line, but here, yeah. Okay, so we have seen how to solve quadratic equation. You've seen how to solve linear equation. You have seen how to solve simultaneous linear equations, and we have seen how to solve a linear equation and a nonlinear equation. Yeah, so something like this. Like, so it could be for this. It could be either it could touch, or it could touch at 2 points, or it could touch at 1 point, just like we saw in quadratic.